Hello students, Namaskar. Welcome in online learning process. I am Mrs. Rekha Kshirsagar from Bitco Junior College. Today, from the topic of electrostatics, we will discuss about applications of Gauss law, mainly two applications: to find electric intensity outside charged sphere and to find out electric intensity outside charged cylinder. And before that, information about Gauss law. Gauss law. See what is the statement. The flux of net electric field through a closed surface equals the net charge enclosed by that surface divided by epsilon 0. Now see here, this is the mathematical form of this Gauss law, and in this surface, if number of charges are enclosed, some are positive, some are negative, Q is the net charge, this net charge is Q. So using this formula, we can find out this total flux. I will explain this using one example. बघूया फाय कसा काढायचा आहे ते. टोटल फ्लक्स इज क्यू अपॉन इप्सिलॉन 0. स्पीक आउट दिस फॉर्म्युला लाऊडली. इमॅजिन या बॉडीच्या आतमध्ये काही चार्जेस आहेत. रेड चार्जेस आर पॉझिटिव्ह, ब्लू चार्ज इज निगेटिव्ह अँड व्हॅल्यूज आर रिटन हिअर. To find out this flux, we have to take algebraic sum of all these charges. So it is written here. लिहिलंय बघा. आता याची व्हॅल्यूज टाका. 2, 1, 4 these are the positive charges and -1 is the negative charge. And do this. 2 plus 1, 3 plus 4, 7 minus 1 that is 6. So 6 upon epsilon 0 this is the value of phi. म्हणजे algebraic sum of all charges divided by epsilon 0. या पद्धतीने आपण फ्लक्स काढू शकतो. मला वाटतं आता हा लॉ कळला असेल. आणखी एक एक्झाम्पल बघूया. काय बघा बरं ह्या ॲनिमेटेड फिगरमध्ये 3 charges are inside, 2 charges are outside. And how to find out flux in this case? We can find out it like this. Again algebraic sum of all charges divided by epsilon 0. But mind here, फक्त बॉडीच्या आतमधले चार्जेस घ्यायचेत, बाहेरचे घ्यायचे नाही. चार्जेस विदिन दॅट बॉडी. लक्षात आलं? म्हणजे हे पण एक एक्झाम्पल आहे. पुन्हा एकदा बघा, इलेक्ट्रिक फ्लक्स काय करतो? इट मेजर्स इलेक्ट्रिक फील्ड थ्रू द गिव्हन सरफेस. हा त्याचा फिजिकल सिग्निफिकन्स आहे असं म्हटलं तरी चालेल. Now about proof. Actually we already proved this in 11th standard, but just to remind, for this imagine this is one surface in which number of charges are enclosed. Out of these number of charges plus q charges at point O. Now at a distance r from this point O we have to consider point P, and around this small area element ds. Now since charge is positive, electric intensity is in outward direction. One more, this vector is area vector that is perpendicular to this area ds, and E cos theta is component of E along this normal. One more point, this d omega is solid angle subtended by this area at O. Now you must not get confused between plane angle and solid angle. For this purpose, imagine this is that area, and by whole this area, angle subtended at O is solid angle, which is measured in steradian, or it is three-dimensional or analogical to cone, cube, sphere like this. While this ds is arc, and angle subtended by this arc at O, this is nothing but plane angle, which is measured in radian, which is two-dimensional or analogical to triangle, square, circle like this. Means you must not get confused between plane angle and solid angle. Now mathematical steps are very simple. This total flux, which is nothing but integral E ds cos theta. Further, this E is replaced by 1 upon 4 pi epsilon 0 q upon r square. Remaining is as it is. Next to this, q upon 4 pi epsilon 0 is out of this integral sign. So integral of ds cos theta upon r square, and this is called as solid angle, which is denoted by d omega. Integral of d omega, it is nothing but 4 pi, and if you will simplify, you will get this phi is q upon epsilon 0. This is true for every charge enclosed by that surface. That's why the total flux due to all these charges is sum of q1 upon epsilon 0 up to qn upon epsilon 0, and this is nothing but q upon epsilon 0, and this is how we can prove this. आता आपण डेरिवेशन घेतलं, त्याच्यात बघितलं की हा डी ओमेगा इट इज नथिंग बट सॉलिड अँगल हुज व्हॅल्यू इज 4 पाय. काय असतो हा सॉलिड अँगल? ॲक्च्युली तुम्हाला सी ई टी वेगळ्या वेगळ्या एंट्रन्स एक्झाम द्यायच्या, बेसिक आपल्याला माहिती असलं पाहिजे. जरीही हे तुम्हाला आता 12वी बोर्डाच्या परीक्षेसाठी एक्सप्लेन करणं अपेक्षित नाही, पण बेसिक माहिती असलं पाहिजे. त्याच्यासाठी हा सॉलिड अँगल म्हणजे काय बघा, अँगल मेड बाय conical surface at O or at center. Imagine this is that conical surface like cone of ice cream, and angle made by this surface at the center. किंवा इथे पण बघा cone like surface, angle made by this whole surface at O or at center. किंवा इथे पण तुमच्या लक्षात येईल. आणि हा फॉर्म्युला आहे त्याचा डी ओमेगा किंवा ओमेगा पण म्हणतात कधी कधी. इट इज अ सॉलिड अँगल अँड इट इज रेशो ऑफ कोणाचा आहे बघा, ए आणि आर स्क्वेअर. ए म्हणजेच काय आहे तर सबटेंडेड एरिया ऑन द स्फिअर, आणि आर ही आहे त्याची रेडियस म्हणजे ए अपॉन आर स्क्वेअर. याने आपण काढतो एरिया किती झाला स्फिअरचा 4 पाय आर स्क्वेअर डिवायडेड बाय आर स्क्वेअर, म्हणून ती व्हॅल्यू किती आली 4 पाय. लक्षात आलं? म्हणजे फॉर युअर बेसिक नॉलेज ओनली आय शेअर्ड दिस. Application of Gauss law. First application, electric field intensity due to charged spherical shell. If question is like this, obtain formula for electric field intensity due to charged spherical shell, then we have to start from diagram. So see this diagram. Consider this is one sphere, which is a sphere on which these positive charges are deposited. At point P, which is at a distance r from center of the sphere, we have to find out electric intensity. For this purpose, we have to consider this point P, and around this point small area element ds. Now we have to construct one Gaussian sphere, which is sphere B, in such a way that this point P must be on this Gaussian sphere. Now, as these charges are positive, electric intensity is in outward direction. If you will draw normal to this area ds, then this is also in this direction. So, direction of E and direction of the normal both are same, or angle between these two is 0. Now here we have drawn this diagram. The way in which we have drawn this, we have to write down description. Means in the descriptive part, these things must be included. Consider A is the conducting sphere on which positive charges are deposited. B is the Gaussian sphere. Q, these are the number of charges are on conducting sphere. R is radius of the conducting sphere. R is the distance of point P from the center. ds is small area around point P. Like this, you have to describe this diagram. Now actually, this is the three-dimensional picture. For better understanding, you must imagine how should be the situation, how should be the pictorial form. For this purpose only, I have shown it here. This is that sphere A on which positive charges are deposited. This is Gaussian sphere B, and on this sphere we have to consider the small area element dS. This is the direction of E, etc. But while in the exam,
question is like this, you will not draw this diagram. You have to draw this diagram only. For better understanding, I have shown this.
इन शॉर्ट काय बघा, आपण कसं काय डिस्क्रिप्शन करणार आहोत. व्हॉट वी हॅव टू डू. आपल्याला कन्सिडर करायचं आहे, दिस इज स्फिअर. हा इनर स्फिअर आहे की ज्याच्या आउटर सरफेसवर आपण पॉझिटिव्ह चार्जेस डिपॉझिट केलेले आहेत. आणि ह्या पॉझिटिव्ह चार्जेसमुळे आपल्याला ह्या पॉईंट पीला, की जो आर ह्या डिस्टन्सवर आहे, इलेक्ट्रिक इंटेन्सिटी काढायची. हा आपला पर्पज आहे. मग त्यासाठी आपल्याला काय करायचं आहे बघा, आपल्याला आणखी एक स्फिअर कन्स्ट्रक्ट करायचं आहे. आपण ते स्फिअर कन्स्ट्रक्ट केलं आहे की ज्या स्फिअरला आपण बी म्हणालो. ठीक आहे. आणि ह्या स्फिअरची रेडियस किती झाली, ही स्मॉल आर एवढी त्याची रेडियस आहे. आणि ज्या पॉईंटला आपल्याला इलेक्ट्रिक इंटेन्सिटी काढायची तो पॉईंट मात्र ह्या आउटर स्फिअरवर आहे असं आपण कन्सिडर केलेलं आहे. आता याचा अर्थ काय झाला बघा, हे सगळे पॉझिटिव्ह चार्जेस जे आहेत ते ह्या आउटर सरफेसच्या आतमध्ये आपण एनक्लोज केले असं त्याचा अर्थ होतो. बाय कन्स्ट्रक्टिंग दिस गॉसियन स्फिअर. लक्षात आलं. हे आपण इथे कन्स्ट्रक्ट केलेलं आहे. एकदा ही थीम कळली की बाकीचं सोपं आहे. तुम्ही ह्या पद्धतीने पण इमॅजिन करू शकता, ह्या पद्धतीने पण इमॅजिन करू शकता. गॉट इट. See actual mathematical steps to find out this electric intensity outside the charge sphere. Now from this figure we can say that these charges are enclosed in this Gaussian sphere. Now we have to use here Gauss law. See different forms. This is the total flux or integral of flux or integral of vector E dot vector ds, or we can write down according to the definition of scalar product or dot product. It is E ds cos theta, which is equal to q upon epsilon 0. These are the different forms. Out of these, we will select this form, integral E ds cos theta, which is equal to q upon epsilon 0. Now we have to use this form too many times. That's why you have to remember this. Now let us start actual mathematical steps. For this, we have started from this step. Now in this case, I told you direction of E and direction of normal to the area both are same. This indicates theta is 0 and cos 0 is 1. That's why we can write down next step as this cos theta is not written here because its value is 1, while left hand side this phi is nothing but q upon epsilon 0 as per Gauss theorem. Right hand side I wrote it. Hereafter, now what is this integral ds? What it indicates? Now we have to collect these small areas ds, and if you will collect it or if we will gather it together, what it indicates? It is the area of this entire sphere. That's why we can write down it as 4 pi r square, which is nothing but area of the sphere. Left hand side is as it is. Next, we have to simplify for this E. Rearrange this equation. We are getting this formula. E is equal to 1 upon 4 pi epsilon 0 q upon r square. Once we already discussed about this formula, which we derived it from Coulomb's law. Now using these 3-4 mathematical steps, you can derive this relation. Second application, to find out electric intensity due to infinitely long straight charged wire. Wire is in the form of cylinder, that's why charged cylinder. This is that charged cylinder whose length is very large, and on this, see, these positive charges are deposited. We have to take this fact into consideration. While considering this derivation, we have to consider small portion of this wire but in enlarged form, and this is taken here. This is the small portion of that wire which is in enlarged form, whose radius is capital R. These positive charges are deposited on this wire. Now in this case also we have to construct this Gaussian cylinder. Here I have drawn it. Draw it with me. Are you drawing this or not? Hope so, yes. L is length of this cylinder. From this cylinder at point P, we have to consider small area ds, which is at a distance r from the center. Now here, since these charges are positive, direction of electric intensity is away from the charge. This is normal to the area. So direction of the normal and direction of electric intensity both are same. That's why theta is 0. Now as per this diagram, we have to write down explanation, and before that, for the better understanding, you must imagine the situation. What is the fact? What is the pictorial form? For this purpose only, I have shown this picture here. This is that long wire which is charged one. This is the Gaussian cylinder which is constructed, whose length is L. On this Gaussian cylinder, we are considering the small area element ds. Direction of E and direction of normal is shown. Means for better understanding only, this diagram and this diagram is shown. But at the time of exam, you have to draw only this diagram. You will not draw these two diagrams. Got it? Now start explanation or description. Write it yourself in your own language. But in the descriptive part, these must be included. A is the conducting cylinder or wire, B is Gaussian cylinder, Q is charge on conducting cylinder, ds is the area element. One more point is here, this lambda. Lambda is nothing but linear charge density, and we discussed about this in 11 standard. But once again remember it, this lambda is linear charge density, which is charge per unit length, coulomb per meter. Remember this, don't forget, and using this concept, we can find out total number of charges on this wire. Clear? पुन्हा एकदा थोडक्यात बघूया काय ते. कन्सिडर ही लॉंग वायर की जिचा सिलेंड्रिकल फॉर्म असतो, आणि ह्या वायरवर आपण काय केलेले, पॉझिटिव्ह चार्जेस डिपॉझिट केलेले आहेत, आणि ड्यू टू दीज पॉझिटिव्ह चार्जेस ॲट सर्टन पॉईंट आपल्याला इलेक्ट्रिक इंटेन्सिटी काढायची. त्यासाठी आपण काय कन्सिडर करणार की ही खूप मोठी लांब वायर आहे, त्याचा एक छोटासा पार्ट आपण कन्सिडर करणार आहे, पण तो पार्ट आपण एनलार्ज फॉर्ममध्ये घेणार आहे, आणि मग तो पार्ट कन्सिडर करून आपण पुढची फिगर कन्स्ट्रक्ट करणार आहोत. मग बघा आता हा जो सिलेंड्रिकल पार्ट आहे, दिस इज द पार्ट ऑफ दिस वायर. याचा आपण पार्ट घेतलेला आहे, पण तो एनलार्ज फॉर्ममध्ये. म्हणजे ऑन दिस सिलेंडर काय झालेले आहेत, हे आपण पॉझिटिव्ह चार्जेस डिपॉझिट केलेले आहेत, आणि ड्यू टू दिस पॉझिटिव्ह चार्जेस ह्या पॉईंट पीला इलेक्ट्रिक इंटेन्सिटी किती आहे तो फॉर्म्युला आपल्याला डिराईव्ह करायचा. त्याच्यासाठी पुन्हा आपल्याला काय करायचं आहे, बघा आणखी एक सिलेंडर कन्स्ट्रक्ट करायचं आहे. हे ते गॉसियन सिलेंडर झालं की ज्याची लेंथ दिलेली आपल्याला L आणि ज्याची रेडियस आहे स्मॉल r. आपण कन्स्ट्रक्ट केलं हे सिलेंडर. लक्षात आलं? म्हणजेच आपण काय म्हणू शकतो की दीज पॉझिटिव्ह चार्जेस हे ह्या सिलेंडरच्या आतमध्ये आलेत. लक्षात आलं? ही थीम झाली. आपण कन्स्ट्रक्ट केल्यामुळे हे चार्जेस ह्या सिलेंडरच्या आत आले. मग आता बघूया इथे कशी काढायची आपल्याला इलेक्ट्रिक इंटेन्सिटी. Now see actual derivation part. Diagram is drawn. We have explained this diagram. Now we have to start from mathematical form of Gauss law. In first derivation also we did it. Yes or no? We have started from this. So start from this. Write down first step. I have written it here. Now what about this theta? Theta काय बघा बरं? This theta is nothing but, imagine, since these charges are positive, direction of electric intensity is outward, away from the charge, in this direction. This is area, and normal to the area is also in the same direction. The direction of E and direction of ds दोघांची सारखीच आहे, त्यामुळे थीटाची व्हॅल्यू आली 0 and cos 0 is 1. म्हणजे this value will be 1, and phi is nothing but q by epsilon 0. Replace it and rewrite. See, I have written. Next to this, now see what this integral ds indicates. if you will consider this small area element and if you will collect all these elements, then what you will get? You will get total surface area of this outer cylinder. हा त्याचा अर्थ आहे, बरोबर आहे की नाही. इंटिग्रल डी एस म्हणजेच एरिया ऑफ दिस आउटर सिलेंडर. व्हॉट इज दिस व्हॅल्यू? किती सांगा? येस, 2 pi RL. This is that area of the cylinder. Remaining is as it is. Next to this, one more point we have to discuss. This lambda is nothing but linear charge density. What is this linear charge density? It is charge per unit length. And why we need this? Because what we imagine, this wire is very long, so too many charges are there, and to count all charges it may difficult. That's why if we know charges on unit length, either on 1 meter or 1 centimeter, then by cross multiplication we can find out total number of charges which are on this long wire. That's why we need this lambda. क्लिअर झालं? म्हणजे युनिट लेंथवर किती चार्जेस आहे हे कळालं की आपल्याला सगळ्या लेंथवर किती चार्जेस आहेत हे पटकन काढता येईल. म्हणून आपण ही लॅम्बडा, चार्ज पर युनिट लेंथ, ही टर्म इथे वापरलेली आहे. मग क्रॉस मल्टिप्लिकेशनने बघा बरं क्यूची व्हॅल्यू किती येईल. येस, दिस क्यू इज नथिंग बट लॅम्बडा इंटू एल. तेच आपण इथे लिहिलं आहे. राईट इट युअर सेल्फ. झालं लिहून. पुढे काय? वी हॅव टू सिम्प्लिफाय फॉर ई. चला करा रिअरेंज अँड दिस इज द फायनल फॉर्म्युला. लक्षात आलं? म्हणजे युजिंग दिस यू कॅन फाइंड आउट इलेक्ट्रिक इंटेन्सिटी. पुन्हा एकदा बघा, शॉर्टमध्ये आपल्याला याचं डेरिवेशन क्वेश्चन असेल तर कसं करणार? आधी पूर्ण ही डायग्राम काढायची, याचं एक्सप्लेनेशन आणि हा सगळा मॅथमॅटिकल पार्ट. ही लॉंग वायर वगैरे काढायची नाही. फॉर बेटर अंडरस्टँडिंग ओनली I have shown.
Thanks for watching. Enough for this lecture. But before going to say bye, read these some lines and see what these lines are indicating. Once again, thanks for the watching.